If a particle traveled along the curve y equal x to the 3 halves from x equals 0 to x equals 4, how far would it travel? So we can look here at the graph and we can see the path that this particle follows. And in order to find out how far it traveled, we are going to find the length of that curve between 0 and 4. And that length is going to be the square root of 1 plus, okay, we're going to need the derivative squared. So let's take the derivative, power out in front, decrease the power by 1. So here's the derivative, and this needs to be the derivative squared. So we're going to have 9/4 x, because if we square this, we'll get x, and then dx. So as we go to evaluate this, we're going to use u substitution, letting u be 1 plus 9/4 x. So our du is going to be 9/4 dx, and we can multiply both sides by 4/9, and dx is going to be 4/9 du. Let's go ahead and do the substitution. Now I have a definite integral, so I can either change these limits of integration or I can do it as an indefinite and then resubstitute. I think I'm going to change the limits. So we're going to have, if I put a 0 in here for x, I get this changed to u, and that's going to give us a 1. And if I put a 4 here, that's going to give us 1 plus 9, or 10. And then we see that we would have the square root of this was u, so I could write that as u to the 1/2, and then my dx is 4/9 du. Now I can go ahead then and do the integration. It's going to be 1 higher power, and then reciprocal of the power here, and evaluated from 1 to 10. So let's go ahead and do that evaluation. We can go ahead and combine these. So it looks like I get 8/27, and then I would have 10 to the 3 halves minus 1, because of course 1 to the 3 halves is just 1. And then if we wanted to know the length of this, we would likely then put this in the calculator so we could see what it is. So it looks like this is approximately 9.07, whatever our units are.